Hello friends, welcome back. Today I am going to teach you about combinational circuit design with the help of a question. So let's come back to the question. In a combinational network is given with 4 input A, B, C and D and 3 intermediates outputs U, V and W with 2 final output, that is X and Y, and the X, Y are given as summation 0, 1, 3, 4, 5, 7, 11 and 15, and Y is the min term 2, 3, 6, 7, 11, 15. So this is the circuit, 4 inputs A, B, C, D, 3 intermediate output U, V, W and some circuits or gates, and then output X, Y. So in the first part it is asked that if G1 and G2 both are AND gates, show the map for the smallest function Vmin with the minimum number of minterms which makes it possible to produce XY. Part B, show the maps for U, V, U, W corresponding to the above Vmin. And part C, design the circuit diagram of combinational network with the help of basic gates. So come to the solution part. In the solution, what is given? The circuit is given and some information is provided. A, B, C, D and input, X, Y are the outputs and U, V, W are the intermediate output. In the question it is asked about the Vmin. It means what should be the V minimum in the terms of min terms, so that if we AND with U and AND with W, it produces X and Y. It is also given that this G1 is AND gate and this G2 is also AND gate. So come to the solution part. How we will create this V? We already know this V is common for both G1 and G2 for one input, and another input are U and W. So if we talk about general expression for V, there are so many possibility, but it ask about the Vmin. It means there is only one possibility which contains Vmin. Okay, so we will find out Vmin. How we will find out Vmin? By using the logic, if X is generated by AND operation and Y is also generated by AND operation, it means this V at least contain whatever the min terms of X and Y. So whatever the min terms of X and Y, V is the union of both. In other word, we can say that V is the XOR of X and Y, OR of X and Y. So let's make the table and it will be little easy to design and draw the function for Vmin, U and W. So 0 to 15, why 0 to 15? There is a 16 combination because there is a 4 input. We know that if the 4 variables, 2 to the power 4, that is 16. 16 combination will be present. Here we have represented the all 16 combination from 0, 0, 0 to 4 times 1. Now come to the X. X is given in the question 0, 1, 3, 4, 5, 7, 11, 15. So put into the table 0, 1, 3, 4, 5, 7, 11, 15, and rest of the term will be what? 0, we know that. Similarly for the Y, 2, 3, 6, 7, 11, 15, 2, 3, 6, 7, 11, 15. We filled this as a 1 and rest of the places will be 0. Now from the previous analysis we have concluded that V would be containing the all min terms or inclusion of all min terms present in X and Y. In other word, V is the OR operation of X and Y. If we perform the OR operation 1 0 1 1 0 1 0 1 1 1 1 1 1 0 1 1 0 1 1 0 0 1 1 1 1 1 0 0 0 0 0 0 0 0 0 1 1 1 0 0 0 0 0 0 0 0 0 1 1 1. Now come to the other two intermediate, because in the question it is asked, if we have this expression or we have this table or the output, then what is the value of or expression of maps of u and w. So first, what is v? Where v is 1, 0, 1, 2, 3, 4, 5, 6, 7 and 11 and 15. So 0, 1, 2, 3, 4, 5, 6, 7, 11 and 15. Now u, we know that we want to put u here. What combination of u we can put? Very simple and obvious option is, since x is generated by the AND operation of v and u, and v is the superset of x, so if we perform u and v, so this will be the deciding factor, and deciding factor what it have to create? It have to create x. So we will take x as it is as the u. So we have copied it. U is equal to min term of 0, 1, 3, 4, 5, 7, 11 and 15. So we have put it this all 0, 1, 3, 4, 5, 7, 11 and 15, and rest of the place is 0. Okay. Similarly, now w, how w is chosen? We know that w creates the AND operation with v, the y output. So but we know the y, so v is the superset of y, so deciding factor is w. So we will choose w for the simplicity, as there's it is y. There is a possibility we can choose u and w differently, but I have chosen for the simplicity y, and so w is equal to y and y is equal to what? 2, 3, 6, 7, 11, 15. I will fill this 2, 3, 6, 7, 11 and 15, and rest of the place is 0. So here our table is completed. Now we have to find out the minimized expression for u, w, v, so that we can create the unknown combinational circuit. Okay. So we have to rearrange it. By rearrange it, input, then intermediate output, then final output. We know that x is created by u and v, y is created by v and operation with w. So you can verify it, table is present here, but for the verification I just see to u and v, 1 1 1 1 1 1 0 1 0 1 1 1. Why it is 1? Because 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. Similarly, v and w create y, 1 and 0 0, 1 and 0 0, 1 and 1 is 1. Similarly, we will verify this all table. So come to the K map for u. We know the expression, so we have to fill this into the K map. So 0 here, 1, 3, 4, 5, 7, 11, 15. You can verify it easily. 15, 1 1 1 1, it means 15. 11, 1 0, 3. This 1 0 1 1, it means 11. So 11 is here. Similarly, after completing this filling of table, rest of the place will be 0. I am not showing it here, just for the sake of simplicity I am not showing it, but you can assume it here it is 0. Now making the grouping, we can see that there is two quad present, one is here and one is here. If we make this quad, the expression for this is a bar and c bar. Why a bar and c bar? Because b is changing and here d is changing. So expression, minimized expression for this is a bar, c bar. Next grouping is this one. Here a, b both are changing, but c, d is not changing. So c and d is the expression for this grouping. Similarly, circuit design, a bar, c bar. So a bar and c bar we have created using this NOT gate, and performing the AND operation we get a bar, c bar. Okay. Similarly C and D, so C and D, this is the symbol of AND gate, so CD is created. This is OR gate, 2 input OR gate, A bar C bar this input and CD is this, is create the U. Next to the Vmin, we have to fill 0, 1, 2, 3, 4, 5, 6, 7, 11 and 15. Here we can see that by filling this K map there is a 1 octet, so we will create 1 octet, and expression for this octet is here C and D both are changing in this direction, but in this direction only A is remain constant, B is also changing, so A bar is the expression for this term. Okay, now next grouping is this one. If we take this, it is pair, but if we include this one, it will create a quad. So making this quad, the term for this quad is C and D because AB is changing. So this is, now design this using the basic gate. So A bar, a NOT gate, create A bar, CD is simple AND operation of C and D, CD, and the 2 input OR gate will create Vmin. Similarly for the W, we will fill this K map 2, 3, 6, 7, 11, 15, 2, 3, 6, 7, 11, 15. So here the K map is completed. Now we can see that clearly there is a 2 quad is generating, one is here and one is here. So first quad, here only A bar is constant and here only C is constant. So the term expression is A bar C. Next term is this group is octet, AB is changing, so no term is present. Similarly C and D expression is created. Now we will generate the circuit diagram using the basic gates. So A bar is NOT gate, A bar created, A bar and C is AND operation, A bar C. Now CD is AND gate, so CD is created, 2 input will create 2 input OR gate will provide the A bar C bar plus CD, which is U. So now we have the final step, complete combinational network for the unknown network in the problem. What was the black box? There was a A, B, C, D input and U, V, min or W is the output. What is inside we don't know. So now we have created the circuit for U, V and W, just we have to fill it. So for U we have created, you know that A, C, D you can directly connect it, but I am not showing it for the complex diagram will become complex, that's why I am not connecting it, I am just representing A, C, D. Next Vmin, we have Vmin. Next W, we have W, and if we want to complete circuit which is provided in the question, yes, in this unknown network how many gates are required? 1, 2, 3, 4, 4 NOT gates are required. 1, 2, 3, 4, 5 AND gates are required. 1, 2, 3 OR gates are required. This is the very easiest and simplest way, but it is not the efficient way, because we can see that here CD, CD, CD all is the input into the 3 OR gates, and we have used the AND gates, separate AND gates for all CD. Same input we are creating and using, but with the different AND gates. So we can reduce it. We will see it further. And this is the complete, and this is the intermediate, and this intermediate is fetched to the G1 and G2, which is AND gate, and it creates the X and Y, and we can replace this G1 and G2 because we know that it is AND gate, then we can replace it by AND gate symbol. So this is the complete network which is asked in the question. In addition, I am just going to give you a brief discussion about how to minimize this number of gates, because 1, 2, 3, these 3 AND gates only create CD output, which can be created by only one AND gate. So minimization of the network. Okay, in the minimization of network, what we will do, we will reduce this excess gates, and it will come to the this number 2 AND NOT gate, 5, sorry, it is 4, currently it is 4 and 5 AND gate and 3 OR gate, it will reduce. How? So this is wrong. What we can remove? Here we can see A bar is created, here also A bar is created, and here also A bar. So we can remove any 2 NOT gate for this A bar, and we know that this AND gate, this AND gate and this AND gate create the CD input. So we can remove 2 of this AND gate. So removing this, now you see here we need A bar. So A bar is already here created, so we will make the connection to the here. And also here we need CD, here also we need CD, we already created CD here, so we can make the connection CD here and here also. Here also we need A bar, A bar is already here connected, created, so we have connect this AND gate with the input of A bar. So see this, we have connected this A bar here and here, which is required, and CD here, here and here. Now the total NOT gate is 2, AND gate is 1, 2, 3 and OR gate is 1, 2, 3. So we have minimized this expression. Okay, thank you. If you have any doubt, you can ask in the comment, or you have any doubt, you can post in the comment. And if you have any specific question and you want a video solution, so join the Telegram group, link is given in the description, you can find it, and join this group and post your question or query, and we will provide you video solution as soon as possible. Thank you very much. Please subscribe my channel and like and share.